This is a video to kind of help out a little bit with section 1.3, mathematical functions, and to help you navigate through some of the trickier problems. Okay, so remember from section 1.2, the definition of a function. It takes a given input and brings it to a single output. I often talk about like a vending machine in this sense, in the fact that with a vending machine, you want to put in a code. When you put in a code, you want to know what you're getting after putting in that code. However, it could be the case that more than one code brings you, for example, to a Diet Coke. That's okay, but you just can't have a code go to more than one place, because that wouldn't be, with a function, you want to know when you input something what you're getting out. And it can't be, oh, you could get out a Diet Coke or you could get out a Sprite. And the graphical test, if we were to look at a graph and see if it is a function, that would be the vertical line test. Because if we're thinking about if every input only goes to one output, oh, that's a terrible color choice. Then if you have this graph, which we'll talk about later, the sideways parabola, that's a problem, because if I take something like, say this number was 3. Well, if you input 3, it has more than one possible y value. That's not a function. Whereas your standard y equals x squared type of parabola, this, if you put in 1, that will go to 1. But if you put in -1, that also goes to 1. They share an output, but each input only goes to one output. Okay, so then we talked a little bit about how the set of all inputs is called the domain, and the set of all outputs is called the range. And some things, when you're thinking about domain, you want to think about what is sometimes we say what's mathematically illegal, what can't we do? And we're talking over the real numbers right now. So I'm not talking, for those of you who know the imaginary numbers and I'm not talking about that right now. So mathematically, you need to take the square root of 0 or a positive number. So whatever's under the square root has to be 0 or positive, and you can't divide by 0. So those are the two main things that we're talking about with domain thus far. So let's go through some of the trickier problems here. Actually, maybe I'll do a basic domain first. Okay, so in this problem 7, I was asking find the domain and range of the following. So range is all the possible outputs. So I want to show you how to do this in a very systematic way. And right now you may think, oh God, this seems like tedious. I don't need to do all these steps. Trust me. If you start thinking like this, then when we do the much harder domain and range problems, it will definitely help you out. So here, when I think about domain, I think about, is there anything I can't put in for x? I'm going to look at k of x here. And no, there is nothing that I can't. I don't have any square root. I don't have anything in a denominator. So my domain is going to be all real numbers, or negative infinity to infinity. We always put this in interval notation. And my range, however, that is going to be restricted, because I always go to where my variable is and I start there. And so I've got this 2, and then x minus 5 squared. Well, the smallest that come out of there, since I'm squaring it, is 0. And then it can get huge. And then I've got plus 11. So let's actually do this out. 2 times 0 is 0. 2 times infinity is still going to be infinity, or huge, infinitely huge. Then you've got plus 11 So the range is going to be 11 to infinity. Okay, so that's kind of how you would think about it. Let's do F2 as well. So F here. So I do have a domain restriction because I need whatever is under the square root to be greater than or equal to 0. So I'm going to solve this easy linear inequality. We're going to do more complicated inequalities a little bit later, probably at the end of this month. So x has to be greater than or equal to 9/2. So putting that in interval notation, my domain is 9/2 with a bracket to be inclusive to infinity. Now my range here, well, the smallest that I can take a square root of is 0. You're never going to get a negative out of a square root. So my range is going to be 0 to infinity. All right, let's go to this next page here. All right, let's find a good one here. Let's do, and this should be, I believe this should be a little squared. It looks, oh no, it's not a squared, it's to the 6. Sorry, I don't know why that one got so tiny. Okay, so let's do O here together. So O, let's start with the domain. And so the domain, again, is just the restrictions on x. And I've got this square root. So I need 5 minus 2x to be greater than or equal to 0, or I need x to be less than or equal to 5/2. So my domain here is going to be negative infinity to 5/2 inclusive. Okay, so now for my range. My range is, out of that square root is going to, I'm going to do my range up here. Out of the square root is going to be 0 to infinity. And I've got the plus 11, and notice I have this negative in front of the square root. So think of the negative as multiplying by -1. So that's going to bring, instead of 0 to infinity, I'm going to have negative infinity to 0 plus 11. And so my range in this case is going to be negative infinity to 11 with a bracket. So that's the systematic approach that you would do with these types of problems. Okay, let's see. Oh, this is only the domain, the last ones. Okay, so for the domain of, maybe let's do the domain of c of x here. So the thing, I don't have a square root, but I do have variables in the denominator. So, and the denominator can't be 0. So that means x cannot be 3 and x cannot be negative 7/5. So putting this in interval notation, I've got negative infinity to negative 7/5 union negative 7/5 to 3 union 3 to infinity. So this is saying everything on the number line except negative 7/5 and except 3. Now the range, be careful with the range here. It can't be everything, because what is happening here is you have a number in the numerator, which means this fraction could never equal 0, right? Because the only way a fraction equals 0 is if the numerator is 0. So my range here is going to be everything but 0.